Welcome to our third lesson. We're going to talk about the groups or the families within the periodic table and how they all share characteristics. So let's go ahead and dig in. We're back to the note packet. So that should be just like we expect on page, let's see what page it is, page 8. We're going to talk about groups. So we'll start with the alkali metals. And this is one of my favorite groups. I'll go through some characteristics and then I'm going to dig right into showing you them in action the best I can. I prefer to do it in the lab, but I don't have all of these elements yet collected. So I'm going to have to show you a chemist, actually from Britain, who she does a wonderful job. But let's go ahead and look at this. What are these alkali metals? Well, they're the group 1. What do they share? They all have one valence electron. They easily lose that one valence electron. Since there's only one of them there, they donate it. And that means they lose something negative, they become a positive. And because they have one electron to give, they become a positive 1 ion. They all share that characteristics. They are extremely reactive, which is the reason I'm going to show you the video. They're extremely reactive, and they're never found alone in nature. So if there was a little bit of sodium free in nature, it would quickly disappear because it reacts so much with water. They contain the most reactive metal, and that's definitely francium. I don't think there's any doubt about it because it's so hard to actually measure, but it's so rare we've got to go with cesium. So I guess we could say cesium is because it's the only one we have access to, and that's CS on the periodic table. All right, but you can tell francium, following that very characteristic, would be more reactive. All right, without further ado, I want to show you a video. So let me pull that up here and bring it over to the screen you can see. And there you go. And let's watch her mix lithium. Or first work with it.
Cut a small piece of lithium. There we go. Pick up the piece of lithium and drop it onto the Petri dish. Pass it around the class so that the audience can get an impression of how light in weight it is. Warn students not to touch the metal. Taping the lid onto the Petri dish is necessary. Next you will need to cut a 3mm cube piece of metal in order to heat in air. Metal on a flat brick.
So
when heating the metal, you need to use a roaring Bunsen flame and position the metal at the top of the blue cone, which is the hottest part.
Let me just pause that there. Isn't that so cool? The red flame to me is amazing. Now the residual. Now I want to show you the next one down. It's sodium, and check how beautiful this cuts. It looks almost like forbidden margarine or something. Let me show you.
Okay. So we need to cut a piece of sodium off this large piece.
Isn't that gorgeous?
You can see the lovely shiny silver surface that tarnishes much quicker than the lithium in air.
Now, of course, I rudely skipped by the part where she explains all of these metals have to be stored in oil. So she's taken them out of the container. They're still stored in oil. She's going to take a small group. She's done, of course, burn it. So that's what I'm skipping the part to. And you'll see a different color flame. And you might wonder, why does it give off different colors? What we learned last year about electron excited states to ground states, that's what's happening.
Again, the roaring Bunsen flame. You see it melting. And reacting with the air.
Okay, I'm going to skip to something even a little bit more dangerous. Let's get right over to potassium. Oh, this is the lithium one. And that's the potassium. Here's water.
Dry it off with a paper towel.
And these are so reactive, even like a fairly safe material like water, look at lithium react to it. That's why they're stored in oil. Now, when you get to go down and move down, you'll see even more reactive ones like sodium.
Finished. You can add some.
Here's sodium. Now it's actually producing heat there. You can't really see the heat. Oh, there you saw some steam. It's enough steam sometimes to ignite the hydrogen that's being given off from the water being stripped. You can just see the heat waves there. All right, let's try. Let's see the more reactive one. Potassium. Now this is crazy. She's going to be nervous about this. Yeah. Check this out. I saw one demo with a chemistry teacher. The thing exploded. I think we got a lot of hits for that one. I have to dig that one up.
Confirm that the gas is indeed hydrogen.
Oh, this is
Add
a great
very
test.
small piece of clean lithium to a little tap water in a boiling tube. Wait for a few seconds and
She's
pop the
nervous.
gas with a lighted paper. A squeaky pop.
All right. Well, okay, guys, I just couldn't go through a chemistry lesson on alkali metals without showing you what they're like and what they're doing. Some of you will just be, I just want the knowledge, but I wanted to give you that stuff. So let me move on to teach you about alkali earth metals. First of all, alkali earth metals are right here. These are the alkali earth metals. And they all have 2 valence electrons. They prefer to lose their electrons as well. There's just 2 of them. And they become positive 2 ions. They're fairly reactive, less reactive than the group 1s, but they are fairly reactive. And they're never found alone in nature for that reason. Now these next metals are this group right here on the periodic table. You'll see this whole large group. Let me see if I can get that working. Yep. Okay. And these are found in the middle of the periodic table. In the D block we call it, because it's filling the D shell. They form colored ions, beautiful colors. For example, copper is bright blue when mixed in water. This concept is always on the Regents exam, meaning they ask you what color does copper turn in water. And so just to let you know as a friendly, no guarantees, but it seems always to end up there apparently. They tend to be unpredictable. Almost every transition metal can form different numbers of bonds. I should probably, sometimes I should slow down when I'm writing. Anyway, the idea is different number of bonds make it unpredictable, which I did a pretty unpredictable job of spelling. So I can't even stand looking at that. So I hope that makes sense. We can't predict in transition metals whether it's in group as you go through the families. We just transition metals. So this is unpredictable. A little bit better, at least semi-legible. All right. They have multiple oxidation states. So you look at nickel. It can have 2 bonds or 3 bonds. It can form a positive 2 ion or a positive 3 ion. Copper can have a positive or 1 or 2 ion. They're most likely found uncombined in nature. That means you can actually dig through the ground. That's hence Minecraft's main principle. Digging through the ground, you can find these metals in their raw form, like iron. The last, well, not the last group, but the second to last group is the BCNO group. So we're looking at boron, carbon, nitrogen, and oxygen. It's not a single group, but they have some interesting things that's going on in it. This is sort of a miscellaneous group. It's full of metals, nonmetals, and metalloids. It's found along the staircase. You'll see that metal line that goes across here. That's the staircase. The last group is the halogens. The halogens are special because they have 7 valence electrons. I should be very careful here. These are this is not the last group. This is the second to last group, called the penultimate group. This is 7 valence electrons. They really want to gain electrons, so they like to gain 1 electron. I shouldn't put a positive sign because they do gain 1 electron, but they become a -1 charge. And so if you remember, the goal of every atom is to become 8 in its valence shell. 8 is great. Hopefully you recall that. They form salts. So sodium chloride is one table salt in compounds. Oops. Gosh, okay. And the compounds are called halides or salts. They contain the most reactive or active nonmetals. And the most reactive nonmetal is fluorine. Big F. So actually, the most reactive metal is francium, and the most reactive nonmetal is fluorine. All nonmetals make up this group. 3 states of matter actually are found in the group. So we got the solid state. We designate that with a small s next to it. We have liquid. We use a cursive L, and then of course gas. And we use a lowercase g. So example, chlorine, Cl, is an example of a halogen. The final ones, the ones with the crown, the last group is called noble gases. They're very unreactive. They don't deem any other atom worthy of bonding with it. That makes them inert. They have an octet. That's another way of saying they have 8 valence electrons. So they have 8 valence electrons. Most are stable. It's definitely the most stable group, and they exist alone in nature. There is an exception, I guess, and that is the exception to the octet rule is, of course, the first one, which is helium. And for it, its happy zone is 2 electrons. Everyone wants to be a noble gas and has 8, so you'll see all sorts of them form that. We have neon, and then both a nonmetal and a gas is hydrogen, and that's sort of weird. Hydrogen's almost its alone, and it can be H2 gas or H positive aqueous or H negative aqueous. Aqueous again means mixed with water. Then we have the lanthanide and actinide series, and they actually belong to the transition metals. So those appear underneath the periodic table on the very bottom. Let's see if there's any more here. And now you just have the practice sheet to work on. All right, let me pause real quick. All right, let's quickly go through these. Which groups are considered families? Give the groups names and the method. So group 1, if you remember those are the alkali group. Group 2, alkali earth metals. Groups, then we have the transition metals, BC and O group, the halogens, and then finally the noble gases. Which group contains elements that typically do not typically react with other elements? Again, I'll let you fill these out and I'll check them in class. I think it's not helpful for me to go through all of this information I just did. So if you have trouble with these questions, just rewatch the video, I would suggest, or ask in class. That's it, guys. Have a great day.